Okay, welcome to this short instructional video where I'm going to show you how to perform the checks of normal distribution on the data that you've collected. So, what we're looking at here is a data set that I've opened up in SPSS. If you haven't watched the introductory video on how to do that, then I suggest you watch that video before this one. We need to have the data in this format. And what I'm going to do is take you through procedures to check whether the variables that we've collected are normally distributed. Now, to do that, we need to look at our Analyze menu. So you can see there's a variety of different menus that we have up here. The only one really that you need to worry about at this stage is the Analyze menu. So if we just open that up, and we're going to come down to descriptive statistics. Now you can use SPSS to calculate a variety of different descriptive statistics. So you can use it to calculate your means and your standard deviations, your medians, for example. I would tend to do that in Microsoft Excel myself, but equally you can use SPSS for large data sets. It might be very useful. We're not going to do that at this stage, but what we are going to do is perform a number of tests to check for the distribution of our data. And they are available under the Explore tab here. So just select that, and you're going to get a menu that looks like this. So in this little box here, we've got our variables. Now for some reason SPSS is picking up variables that we don't actually have in our data set. But that's alright, don't worry about it. But we can see here that we've got our participant, our sex or gender variable, we've got age, height, weight, and BMI. And in this video, I'm going to show you how to check the distribution for, we'll just do height and weight in this particular example. We'll do them individually, just so you don't get confused. So we'll start with height. We want to check that variable, so we're going to bring it across to our dependent list in this box here. So let's just bring it across. Sorry, my mouse is being a bit temperamental. So our height is in our dependent list. We don't need to add anything to our factor list, and we don't need to add anything to our labels case by. So you can just ignore those there. The only one we need to add is our dependent list. Now, in order to perform the test we want to perform, we need to look at our plots options, and we need to look at our options tab as well. So let's just look at plots. Now, if you remember, the first thing we want to check is a visual check of our normal distribution curve. And if you remember, the type of diagram that we're going to use to do that is our histogram. So you can see at the moment we've got stem and leaf checked. We don't want that one for just now, but we do want to look at the histogram of our data set. And we could just do that visual check, that would be fine if you wanted to do that, but we also, if you remember, we said we want to perform an objective test of whether or not our data is normally distributed. In order to do that, then we're going to check this box here called Normality Plots with Tests. So let's just check that, and then this is set up fine already. Box plots, actually we probably don't need. We can keep it checked if you want, but for now I'm just going to hit none. And continue. And then we'll just check our options box here and just make sure that we're excluding values list-wise. So just make sure that one is checked. It should be by default, and we can click continue. We don't need to look at the statistics box, and we don't need to look at the bootstrapping option. So now we're ready to perform our test. So we'll hit OK. And now we're going to get an output that looks like this, okay? Now, don't be put off by this output. It's literally just knowing where to look for the values that you're interested in. Okay, so it tells you a number of different things about the data that you might be interested in. So, just simple values up here, case processing summary. So you can see here, this is our variable height. We've got the number in our sample. So it's a number of different participants that we have. So we have 33. And it's told us that it hasn't excluded any missing data. So we've got 100% of the values in the analysis. So that's fine. And then we've got a box of descriptive statistics. So you can see here, it's already calculated our mean. and our standard deviation for us, and also our variance. So if we wanted to, we could take our means and our standard deviations there to present in our figures or our tables. We've also got the minimum value, the maximum value, and the range if we were interested in it. Okay, we're not interested in that for this particular analysis. We're interested in looking at our histogram, and we're interested in the outcome of our statistical test of normality. So I'm just going to flick down to the histogram first. So this is our histogram. Now remember that what a histogram shows you is your variable along here, whatever it is. So in this case it's height. And it shows you then on the y-axis the frequency with which that value, that measured value, is occurring in your population or your sample. And as we might expect, and as we showed you in the videos before, you can see that height in the population that we have, the sample, sorry, that we have of 33 participants, it follows that normal distribution curve. Look at it. It looks really good. So we'll actually, visually, we would probably be fairly confident from this histogram that our data is going to be normally distributed. It looks like that classic bell-shaped curve that we showed you in the other videos, remember? But we always want an objective measure of distribution as well, so we can check that. So if we just flick up again in our output, we've got a box here that's called tests of normality. And you can see here, here's our variable height, and then it's performed two different statistical tests. Now the one that we're interested in is the Shapiro-Wilks test. That's the one that I would recommend that you perform for all your analysis that you do across your degree program. And if you remember, what the Shapiro-Wilks test does is tests the hypothesis that our data is not normally distributed. And it calculates a probability value, a p-value, which is denoted here by the significance box. Remember, we can say things based on our probability value that they're either significant or not significant. And this is our p-value here, so SPSS calls the p-value sig. And we've got a p-value here of 0.329. And what that means is that we do not accept the hypothesis that our data is not normally distributed. So if we had a p-value lower than 0.05, it would mean that our data was not normally distributed. But in this case, it's above 0.05. So as we look at our histogram, we're fairly confident it's normally distributed, and our statistical test is suggesting that that's the case as well. So we are confident that our data is normally distributed. Let's just have a look at another example for you then. So we'll close this one off. We're not going to save it. And we're going to go back to our data here. So let's just open up our menu again. So Analyze, Descriptive Statistics, and Explore. And this time I'm going to look at weight. So let's have a look at our weight, or our body mass. All the options should be still ticked, so histogram is selected, normality plots with test is selected, so that's fine. So let's just hit OK. And we're going to get a similar output, but this time we've got weight instead of height there. And we're going to come down and we're going to look at our histogram. Now, this case, our histogram looks very different, doesn't it? We don't seem to have a normal distribution curve here. Okay, so in this case you'd be looking at this data and thinking, well, okay, well, I'm less confident that it's normally distributed because we've got quite a spread out frequency of data occurring across the range of values that we've observed in our sample. So here is really, really important that we're looking at our statistical test of normality. So we're going to flick up here again and we're going to look at our statistical tests. And again, we're looking at the Shapiro-Wilks test. And again, actually, even though visually it doesn't look like our data is normally distributed, what our Shapiro-Wilks test is suggesting is that it's not, the data is not skewed enough to say that it differs substantially from a normal distribution. Remember, if our p-value is lower than 0.05, we would say that it was substantially different from a normal distribution. But that doesn't seem to be the case here, even though our histogram maybe looks slightly less like it's normally distributed. So that's why it's important to be performing these objective measures over normal distribution. What this is probably actually essentially saying is that if we had a lot more people in our sample, a lot more participants in our sample, that over time then this would average out over to a normal distribution. So we've got the beginnings of normal distribution here, that if we added more participants to, then that normal distribution curve would come out. Okay, so that's the end of this video.